All right, chapter 10, last section, 10.8, multiplication rules and conditional probabilities. We are going to use multiplication rule for independent and dependent events. Take a moment, maybe for your notes, you want to make a distinction here. In 10.7, we learned the addition rule. Okay, and in 10.8, we're using the multiplication rule. The addition rule had to do with or problems. The multiplication rule has to do with and problems. And for the addition rule to be able to use it, you have to understand what's mutually exclusive events versus not mutually exclusive events. Well, for the multiplication rule, you have to understand what is independent versus dependent. Okay, remember, if it's mutually exclusive, you're adding two probabilities together and getting your answer. If it's not mutually exclusive, you are subtracting the overlap. Okay, independent and dependent events change the multiplication problem as well. So let's look at that. The probability experiment of tossing a coin and rolling a die and getting an outcome of tails and a 1 involves independent events. Tossing a coin, whether it's done at the same time as rolling a die, after or before, the results are independent of each other. When we multiply the probabilities of getting tails, that's half, right? Heads or tails, that's 1 out of 2, times the probability of rolling a 1, which is 1 out of 6, we use the multiplication rule and multiply 1 over 2 times 1 over 6 and get 1 over 12. We did that quite a bit in one of the other lessons. I think it was the first lesson for the chapter. Okay. Now we know it's called the multiplication rule of probability. Okay. And then also in the first section, we picked colored balls out of a container and did not replace them. When we picked out the first pick, that affects what's going to be picked second. So this experiment, this action, this statistical experiment was involving dependent events, when an outcome of the action is dependent on what occurred at the other action. So rolling a die and flipping a card in an event are independent. But when you pick a second card out of the same deck you picked a first, that would be dependent. Okay, so try to think about it that way. When they're dependent, they are conditional probabilities. Okay, it's conditioned on what happened first. Okay, so we're going to use the formulas for the multiplication rules, the and the given is involved in here. Okay, so we had done some givens in the last, actually a couple last. So picking out a blue ball, given that we've already picked one blue ball, or picking an ace, given that we've picked a king before, that kind of thing. Okay. So when you're doing independent events like we did before, it's just that probability of like rolling a 2 times that probability of spinning a 6 or something like that. Okay, just multiply them together like we did. But when you have a dependent event, we have to think about givens. The givens are designated by these straight lines. It's kind of like an absolute value bar, is how I had to type this in. You might see it slanted a little. Either way, it means the probability of B, given that A already occurred. Okay, probability of B, given that A already occurred. When it's written like this is the probability of A, given that B already occurred. Okay, so I'm trying to think of one that we just did. The freshman and sophomore, given that they're a sophomore, it's a female. So, things like that. We've seen the word given before. Just make sure you're understanding that. So where that comes in is in a dependent event, and you have an and, we're still multiplying, but we're multiplying the probability of the first one times the given of the probability that happened first. Okay, so if B happened first, we're writing it this way. All right, so let's see how this works. So here's a bunch of examples. Any one card chosen from a standard deck of cards. Picking a queen. There is 4 over 52, which reduces here. Picking a king, same thing. Picking a queen, given you've already picked a king and replaced it. So if you put it back in the deck, there's still 52 cards there. There's still 4 queens left. So that's still the same. Okay. Picking 2 cards, though, let's see. So this is kind of picking 2 cards, but you replace it. So its math is just picking 1 card. Okay. Picking 2 cards. Picking a queen, given you've already picked a king. That means it's not put back. Okay. So if you've already picked a king, there is 1 less card in the deck. So it's 51. But there are still 4 queens. Okay, so this is a given. This is one of these, okay? Straight up. Remember, givens have different denominators. Picking a queen and a king, replacing the king before picking the queen. So we put it back. So this is kind of the same as this one, okay? Watch the wording. Picking a queen and a king. So probability of picking a queen, and then assuming we picked a queen, because that's the only thing that would work, is we then pick a king. Well, we pick a king out of a deck that already had a queen missing. So there's 4 kings still there, okay? So this is the probability of a queen times the probability of, so let me write this. There's a probability that this is a queen times the probability a king, given that you've already picked a queen. Okay, so then you multiply across, and reduce. All right, and then the probability of picking 3 jacks in a row. And there are ones, quite a few ones like this in the homework. So picking your first jack. We haven't picked anything yet, so there's 52 cards in the deck. There are 4 different jacks available for our first pick of probability of picking our first jack. All right, given that we've picked a jack, already, we want to pick another jack. Okay, so there's 51 cards left and only 3 jacks left. Given that we need to pick another jack, and I'm not going to go on with the symbols. They're not going to ask you for symbols in your homework. They're just going to want to see this math here, okay? There's 2 jacks missing, so there's only 2 jacks left. 2 cards missing, so there's only 50 cards left. And then we're multiplying all 3 together. So this, depending on how this is asked, they may ask you to round it to 4 decimal places. So this would be 0002. If they want it rounded to percentage, it's a 0%. So just be careful how you're putting that in. Okay.